In this lesson, we're going to look at how to find the lowest common multiple and the highest common factor of a pair or more than a pair of numbers using prime factors. We do this by first finding the prime factors of each of the numbers we're interested in. We have to write them as a product in exponent form for this method to work. Now you could use a factor tree to work this out for your numbers. To find the lowest common multiple, it's actually the product of all the different prime factors and the highest power of the common prime factors. The highest common factor is the product of the common primes only to their smallest power. The best way to see this is by an example. So here we're going to find the lowest common multiple and highest common factor of 105 and 90. So we'll start with 105. What are two numbers that go into that? Well, it ends in a 5, so that means 5 goes into it. And 5 goes into 10 twice, and nothing to carry, and into the 5 once. Now 5 is a prime, so we'll circle that, and that branch ends. Now 21 is equal to 3 times 7. And that ends those two branches because 3 and 7 are both primes. So 105 is equal to the product of those numbers. And before I make a list, I'm going to do 90 first. Now 9 and 10 go into 90. But they're both composites. So I've got to think of 9 as 3 times 3. And 3 is a prime, so that is the end of those two branches. 10 is equal to 2 times 5. And those two numbers are also primes. So I'll be able to write 90 as a product. So the smallest one first for 105 is 3 to the power 1 times 5 to the power 1 times 7 to the power 1. For 90 I get 2, and there's only one 2, times 3 times 3. The shortcut way of writing 3 times 3 is 3 squared. That takes care of those, and there's only one 5. Okay, so the first thing we're going to do is figure out the LCM. And we're looking for the different primes. Now, both lists have 3 and 5. So 3 and 5 are common primes. The different primes are 2 and 7. So that goes into our product straight away. The next thing we look for is the highest power of the common primes. Now 3's the common prime and its highest power is 3 squared. And 5 is a common prime and its highest power is 5. So the lowest common multiple is 2 times 7 times 3 squared times 5. Now you can use your calculator to do that if you want. So let's have a look at what the answer is. 3 squared is 9, 9 times 5 is 45, 45 times 2 is 90, and 90 times 7 is 630. Pause this and check that on your calculator if you wish. Okay, so now for the highest common factor of those two numbers, 105 and 90. This time we're only looking for the common primes and to their smallest power. The common primes are 3 and 5. For 3 the smallest power is 3. 3 to the power 1. 5 to the smallest power is 5 to the power 1. So it's a nice and easy one. So 3 times 5 gives us a highest common factor of 15. Let's do another example. We'll do the same thing, but this time we'll look at 48 and 120. So we'll start with 48, and it's an even number, so 2 goes into it. 2 times 24, and 2 is a prime. 2 goes into 24 again. 2 times 12 is 24, so 2 is a prime, so that branch finishes. 2 times 6 will give us the 12, and 2 is a prime, so that branch finishes. And finally, we end up with 6 being 2 times 3. They're both primes. That ends our factor tree for 48. And if I write 48 as a product of its primes, it has 4 2's multiplying, so that's 2 to the power 4, and 1 3, which is 3 to the power 1. So we're going to do 120. Again, it's an even number, so 2 will go in. 60 times 2 times 60 is 120. 60 is also even, so it breaks into 2 and a 30. And so that branch is finished. 30 is even as well, so 2 will go in again. 2 times 15. And so that branch is finished. And finally, 15 breaks down into 3 times 5. They're both prime, which finishes the factor tree for 120. So let's list that as a product of its primes in exponent form. Smallest first, 2 times 2 times 2, 2 to the power 3. Only 1 3, and only 1 5. You can check these with your calculator anytime to see that it's true. 2 to the power 4 times 3 will be 48. 2 to the power 3 times 5 will give you 120. Now let's find the lowest common multiple first. Now remember, firstly, we put the product of the different primes. Well, there's only one different prime here, and that is 5. I forgot to put that to power 1. So 5 goes in. Then we look for the common primes, 2 and 3, to their highest power. Now the highest power of the common prime here, 2, is 2 to the power 4. And the highest power of the 3 is just 3 to the power 1, because they're both the same. Again, so here we've got a multiplication to do now. 2 to the power 4. 2 times 2 times 2 times 2 is the same as 4 times 4, which is 16. 16 times 5 is 80, and 80 times 3 is 240. Again, you can pause this and check if I did that right. Hopefully I did. And now we want to find the highest common factor. The highest common factor is the common prime factors, 2 and 3, to their smallest power. So 2 to the smallest power is 3, and the 3's have the same power, so the smallest power is 1. 2 to the power 3 is 8, and 8 times 3 is 24. It's a pretty nice method, particularly if you can't do it by inspection. It doesn't mean you have to do it this way. Sometimes it's easier to just figure it out by inspection. But this also works when you've got more than 2 numbers, like if you have to find the lowest common multiple or the highest common factor of 3 numbers or even 4 numbers. Okay, so your learning task is to pick a 2-digit composite number between 50 and 100 and a 3-digit composite number between 120 and 601, and find the lowest common multiple and the highest common factor of them, showing your work as I have done here in this video. Now I don't want you to just do it for one pair of numbers, but do this for 2 different pairs of numbers, and that's your learning task.